Hi everyone, in this video I'm going to be going through 10 non-calculated questions that you can use to help you revise as you prepare for your GCSEs. So let's get straight into them. If we look at this paper, question 1 is a rounding question. So we are trying to round this number to 3 decimal places. So my trick is to kind of look at those 3 decimal places. We want to round it, so it's either going to be 7.264, it either stays the same, or it rounds up to 7.265. How we determine if it rounds up or down is the 4th decimal place, okay? So that 5, if it's bigger than 5, bigger than or equal to 5, it always rounds up. So we know this one, it is going to round up. And so we just write 7.265. The only thing to be careful of, some people get a little bit tricked when they say 3 decimal places. They think you need to move the decimal place, so you don't. You just want to write everything else the same, just cut it off at 3 decimals, see if you need a round. Question 2, we want to write 360 as a product of prime factors. So as soon as you see this product of prime factors, you know that you need a prime factor tree. So you would write 360 and then we try to break it down. So it doesn't matter how you break it down, you should get the same final answer no matter how you choose to divide. My trick is to usually try divide by 2 or 3 every time. So 2 is a prime factor, so as soon as I write down a prime factor, I just circle it just so I can keep track of it. So we're going to say 360. We can split that and say it's 2 times 180. Okay, you might not know that straight away, so if you didn't know that, you could write down your division, 360 divided by 2. So you can say 2 into 3 goes 1 time, remainder 1. 2 into 16 goes 8 times. 2 into 0 goes 0 times. Okay, so that would be your method if you didn't know straight away. Then we want to break this 180 down. So we could say 180 is 2 times 90. Again, we circle 2 because it's our prime factor. Keep breaking it down. So it's easiest if you keep your prime numbers on the left-hand side to keep track of them. 90, we could say, is 2 times 45. So we are getting there. Then 45, we could say that is 5 times 9. And then finally, we can say 9. If we break that down, we could say 3 times 3. So once you reach that point where both of the numbers are prime numbers, then you know you've reached as far as you can go. Okay, so this is a 3-mark question. So you would get your first mark for drawing this tree. Your second mark is for writing the product of prime factors. Okay, so we can either write 360 as a product, or we can write it in index form. Product just means we take all these prime factors and we put them next to each other. So 2 times 2 times 2 times 3 times 3 times 5. That is what they're looking for. Your 2 marks here are for, is it in this product form? So have we listed them all like this with multiplying between them? And is it from smallest to biggest? So we go 2s, then 3s, then 5s. That's all they wanted for this question. Just so you're aware, if it was another question, if they asked you for index form then. So index form, very similar. We just kind of group the 2s together. So we could say we have 3 2s. So 3 2s. We have 2 3s. And we have 1 5. So that would be our index form, which we didn't need for this question, but just in case. Question 3 here, we have a ratio question. So I would say as soon as you see it's a ratio question like this and they want us to write a fraction, a good trick is to first get all your bearings with what we've got. So here we've got black pens, green pens, and the really important thing if we're working with fractions is we need to have also totals. Okay, so we can see in this ratio, the ratio of black pens to green pens is 2 to 5. Okay, so we've got 2 black pens, 5 green pens, which means in total we've got 7 in total. So the fraction of pens that are black are going to be 2 black pens out of the 7 in total. Okay, that's why it's really important to list it like that. Some people see the ratio and immediately just go, oh, okay, well that means it's 2 out of 5. because of that ratio, but it's not because we need that total, so that's why we've got to work out that 7. Question 4, we have another ratio question. So again, I would use exactly the same method. So here we're looking at chocolates that contain nuts. So let's just say nuts, chocolates that don't contain nuts. And again, with ratio and fractions, we're always going to have a total. So here we have some chocolates in a box. A quarter of the chocolates contain nuts. Okay, so 1 out of the 4 chocolates contain nuts. So we can say one of them contains nuts. With a fraction, this bottom number is our total. So we've got 4 in total. And that means that the chocolates without nuts has to be 3. Okay, so there's 1 with nuts, there's 3 without. So in total we have 4. They want the ratio of the number of chocolates that contain nuts. Okay, so we want the nuts chocolates to the no nuts chocolates. So we would say there is 1 chocolate with nuts, there are 3 without nuts. So that would be our ratio. This one they say write your answer in this form 1 to n. That just means we want this first number to be 1 and whatever the second number is fine. Okay, sometimes it would just be if we had like a 2 in this position, we would have to then simplify. So that is as far as we need to go for this question. Question 5, we've got a negative number question. So we need to try figure out what numbers we can use to get to negative 7. So you have 2 options here. You could say I start with 2 and I take away 9. That would give me my negative 7. Okay, because if you think of a number line, if I start at 2, if I start at 2 and then I jump back, so to 1, 0, minus 1, minus 2, minus 3. If I keep jumping like that, if I jump 9 spots, I'm going to get all the way to negative 7. Okay, and it's 9 spots to the left, that's why it's negative 9. The other option is we could start at minus 9 and then add 2 and we'll get minus 7. Okay, so we could write it the other way around. Question 6 is a standard form question. So my trick for standard form is to usually try to get it into ordinary form before I do any workings. So here we've got 1 metal box has a weight of 8 times 10 to the 3 grams. So my first step would be to just convert that metal box weight into ordinary form first. So 8 times 10 to the 3 grams, we can just say that's 8 with 3 zeros, so 8,000 grams. Now we want to find in standard form the weight of 10 of these boxes. So let's just work out in ordinary form first, so just the normal numbers. 10 of these boxes, so that would be 10 times that 8,000. Okay, so we're going to get 80,000 grams. And then, really key that we remember, they do want it in standard form, our answer. So then we're just going to say 80,000 grams. We can rewrite that with standard form as 1, 2, 3, 4. So 8 times 10 to the 4 grams. Question 7, we have got index law question. So with index laws, we need to work out usually the top part of the fraction first, and then we see what else we can do. So if we write this fraction, so 3 to the 4, 3 squared. Okay, they say write it as a power of 3. That just means simplify it as much as you can and then keep your answer with 3 to the power of something. So at the top here, we can work out using index laws. So 3 to the 5 times 3 to the 4. With index laws, if we are timesing them, we can just add the exponents or add the index. We're not going to do anything to the bottom yet. So we get 3 to the 9 at the top and 3 squared at the bottom. Then also with index laws, if we are dividing two numbers with the same base and indices, we can then write it as 3 to the 9, take away that bottom one, 3 squared. And so we're going to end up with 3 to the 7, which is our final answer, and it is We're going to leave it like that because they want it as that power of 3. So we don't want to work it out then after that. 7b and c are then also index law questions. So these ones, you have to just know any number to the power of 0 is just equal to 1. So it doesn't matter what the number is, it's always equal to 1. And for part C, we want to write down the value of this. So they actually want us to work this one out. So how we can simplify this is any negative index, we can rewrite it as 1 over the positive index. Okay, that's the start. Now we can work this out. So 3 squared is 3 times 3, so that is 9. And then you could leave it in this form as a fraction. You could work it out if you wanted it as a decimal, but that would be good enough if you can just get it to this point where it's a fraction. So you get rid of that index essentially. Question 8, we've got a ratio question. As soon as we see a ratio question, I would usually write my ratio out. So we've got juice and water. Okay, so they say for every 100 milliliters of juice, you are going to add 2 liters of water. So yeah, in this question, this is the ratio that they give us, and then they want us to work out then obviously a different ratio. So Dev uses 5 liters of water to make the drink. So we want to know how much juice does he need for that drink, and then how much liquid in total would he have. So with ratio, how it works is we always see what did I do to the side that I do know. So I've got both values here. So we need to figure out what did I times or divide this one by. So 2 times 2.5 would give me 5. Okay, so that's what I've done to that side. I have to do exactly the same to the other side. So 100 times 2.5, which is going to give me 250 milliliters. So this was the first mark for this question, is working out that missing part of the ratio. Then we want to know how much drink has he made in total. So that would be, I've put 5 liters of water, 250 milliliters of juice into a glass or a flask. And now I want to know how much do I have in total in this glass or flask. So we've got 5 liters, which is the same as 5,000 milliliters. And we have added that 250 milliliters of juice. So in total, we are going to have 5,250 milliliters. Or you can rewrite that as in liters. So divide by 1,000 and we would get 5.25 liters. So either one of those would be acceptable there. They haven't said if they want it in milliliters or liters. In question 9, we've got an estimation question. So this is, you've got to be really careful for these. They do sneak this word in here right at the end here. So Mel drives a bus for 39 weeks in a year. She drives the bus an average of 298 miles each week. Okay, so 39 weeks, 298 miles. We want to work out an estimate for the total number of miles that she drives the bus in 1 year. Okay, so as soon as you see that word estimate, we need to round both of these numbers before we start doing anything else. We always round to one significant figure, so we always round to whatever the biggest number is. Okay, so this 39, we're going to round it to the nearest 10, which would be 40. And then this 298, we're going to round it to the nearest 100, which would be 300. And then we would work out an estimate, or would work out the total just as we usually would. So we want 40 miles times 300 weeks. So 4 times 3 is 12. And we just add all these zeros on. So we're going to get 12,000 miles per year. The second part of the estimation question is usually, is this an overestimate or is it an underestimate? How you would check this is you would check what you rounded your numbers. So we rounded this number, we rounded it up. So that would be over. And this 298, we also rounded it up. So because we rounded both numbers up, this would be an overestimate, so it's more than the actual amount. And your reason would be something along the lines of, we rounded both numbers up. And finally, question 10, we have an error interval question. Sometimes this is called error bounds or just bounds. So we want to essentially know a number y is rounded to two significant figures. Okay, so maybe we had 3 or 4 figures before. Now we're rounding it down to two significant figures. And the result is 0.46. We want to write down the error interval. So we want to know actually all the numbers that would have rounded up to 0.46 or all the numbers that would have rounded down to 0.46. So how you would do this is I would usually write 0.46. I would write it as 0.460. Doesn't make a difference, just makes it easier for me to see. So I want to know all the numbers that rounded, if I just look at this part, to 460. So 455 would be the first number. That one would round up to 460. And then we could keep going. So 456 would also round up to 460. 457 would round up to 460. Okay, so all of these numbers would have rounded from 3 decimals down to the two significant figures. So what this is we can see the smallest number that rounds up is this 455. So that is what we call our lower bound of an error interval. Okay, so it starts at 0.455. All of those numbers round up to y. Then we want to know the biggest number that rounds down to 0.46. Okay, so if I had 0.461, that would still round down. 0.462 would round down. 0.463 would round down. And we can keep going like that. The biggest number that would round down would be 464. So we say everything less than 0.465 would round down. It is a little bit strange at first with these error intervals. Your trick is always you're going to try find 5 at the end of both, okay? So it's this range. So all of the numbers from 0.455 to 0.465 would round to 0.46. I hope this video helped a little bit to help you prepare for your non-calculator exam. If you have any questions, please feel free to let me know in the comments.